Okay, on this podcast I'm going to show you how to do the graphing exercise on the practice problem that has on the top the effect of mass on volume of a metal. Even though, of course, I did the title backwards, it should be the effect of volume on mass. Okay, but what we're going to do is the first thing we want to do is we look at this. It looks like it's going to make a line, so we want to do a line of best fit. So I'm just going to go ahead and make a line. And let me see. Let me move that over a little bit. Actually, it's a little better if it comes down like this. So that looks like a pretty good line. Don't you think? Okay. So I got my line of best fit, and because the slope, remember the slope is the change in y over the change in x, right? So slope, which is we usually label as m, is the change in y over the change in x. And because in this case the change in y is the change in mass over the change in volume, and that equals density, so therefore the slope and the density are the same. Okay? So if I want to do the change in y over change in x, what I have to do is find 2 points that are on the line. So they've got to be on this black line. They do not need to be a data point. Okay, so I'm going to pick 2 that I think are relatively easy to read, and it looks like none of them actually are on the intersections. So I'm just going to pick this point right here, and I'm going to draw a, whoops, I'm going to make that a dotted line. I'm going to make that a dotted line to the y and a dotted line down to the x. Okay? And then I'm going to pick another point. Let's just say it's this point right here. I'm going to take it to my y and take it down to my x. Now I think I need to move that over just a tad. I think I just, here we go. Okay, so this distance here, hold on. This distance here is my change in mass, right, which is my change in y. And this distance here will be my change in x. Okay, which is my change in volume. Alright, so let's go ahead and figure out what those points are. Now, the way you read a scale on the graph is the same as the same way you read a scale on a graduated cylinder. So I can read to the 100, so I want to report to the 10. So this looks like about 100 and, what do you think? 100 and, I can read to less than 110, so this is 120, this is probably 110. So that's about maybe 125. So it's going to be 125 grams minus this mass, which looks like 40 grams. It's about 40.0 grams, right? Over my change in volume. This is 9 milliliters. 9.0 milliliters, right? I can estimate in between here. 9.0 milliliters, and this is going to be about let's say 2.8 milliliters. Okay, and then I can divide those, and I have 125 minus 40 gives me 85 grams over 9 minus 2.8 gives me 6.2 milliliters. And if I divide those, I get 13.7. It seems high. 40. Oh, I really messed this up, right? This is not 125. 125 is way up here. So this is 100, and this is 110. This would be 105, so it's more like about 104. Sorry about that, but you know, we all make mistakes. That's why we practice, right? So 104 minus 40 gives me 64. That's more like it. 64 grams over 6.2 milliliters. So I divide by 6.2, and I get 10.3 grams per milliliter. And in fact, that is closest to silver. Okay. So what I want to write for my argument is, which metal is it? Okay, so we're going to say the metal is silver. Now if you look at that data, it says looks like about 20 samples were measured for mass in grams and volume in milliliters, and data was plotted, and I know my writing is hard to read. Data was plotted, and since density equals mass over volume, it's also equal to the change in y over the change in x, which is equal to the slope. Therefore, density equals 10.3. I think it was 10.3. Is that right? All right, 10.3 grams per milliliter, which is closest to silver. Okay, now it asks for the percent error. So it's always good to show the formula. So the percent error equals my actual minus my accepted, always over the accepted, times 100. Now this is the absolute value. Okay, so my actual is 10.3 grams per milliliter minus the accepted, which is 10. Let me see, what was silver? 10.5 grams per milliliter over the accepted, which is 10.50 grams per milliliter. And of course this is the absolute value of this, and if I multiply it times 100, I'm going to get 10.3 minus 10.5 divide 10.5 equals divide 100. I get the wrong answer. 10.3 minus 10.5 equals divide by 10.5 equals times 100. I get a 1.9% error. Okay? It actually says negative on my calculator, but I know it's the absolute value, so that's going to be a positive. Okay, so now it says write the equation for the relationship. Now, what we know is y, the general form for a line is y equals mx plus b. So remember we said in chem, we know what y is, and y, in our case, is the mass in grams is equal to my slope, which I already calculated, right? 10.3 grams over milliliters times my x, which in our case is volume in milliliters, plus b. Now let's go back and try to read b off the graph. Alright, so b is this point here where the y crosses the line crosses the y-axis, and that looks like 10 grams. Alright, so we're going to say plus, let me erase that actually if I can. Alright, the eraser's not working, but hey, I can pick the eraser up here. Alright. Plus 10 grams. Now there is one more step you should take, which is to determine whether or not this y-intercept is significant. So what that means is if I'm using this equation to solve for, I have a known volume to figure out what the mass is, we're going to decide whether this makes any difference, any significant difference in the number. And the rule we use is the 5% rule. And it's if the y-intercept over the y-max is greater than 5%, we need to leave that there. And if it's not greater than 5%, we can drop it from the equation. So let's figure out what that is. So let's go back to the graph and take a look. So the y-intercept is 10 grams, and the y-max is going to be my highest y value that I plotted. So this looks just about 102 maybe. Alright, so my y-intercept was 10 grams. My y-max is 102, and multiply that times 100, and I get, it's going to be about 10%. 10 divided by 102 equals times 100 is 9.8%. So the y-intercept is significant, and you should show this work, right? So I go back and I circle my answer. Okay, that's going to do it. If you missed any of that, just rewind, watch it again.